One more theorem is the irrational root theorem, and it basically is saying if a plus b radical c is a root, then so is a minus b radical c. And so it's basically telling you they come in pairs. And you kind of know this already. We did that example on the back page. Let's look at that again for a second. We did this example on the first page where we came up with these crazy zeros. And you know from quadratic formula that anytime you have 1 plus a square root, you also are going to have 1 minus a square root. That's always going to be the way it works. And so that's what this irrational root theorem is going to be talking about. Let's take a minute to do what we did before. Give us some practice of listing out all of the possible roots. And so remember, this is my P, this is my Q. I need to list out all of the possible factors. Why don't you pause it and see if you're able to do that? Okay, the factors are plus and minus 4 over 1, plus or minus 4 over 2. Well, 4 over 2 is just 2. Then going down, the next factor, because like the factors of 4, we could have 4 and 1 or 2 and 2. So if I go down from there, then my next factors are positive and negative 2 over 1, positive negative 2 over 2. Well, that's just 1. And then positive negative 1 over 1, and also positive negative 1 over 2. And so here are my possible roots. If I go to my calculator and I graph this, take a second to do that. Put this new equation into your calculator. Okay, if you put this function into your calculator, go to Zoom Standard, and you should get this graph. And the purpose of this, what we're trying to do is we're trying to see, do these intercepts, any of them, fall in our list? So here we have our list of possibilities. Well, the only one that it might be, because look, this one is not at a whole number for sure. The only fractions I have on my list are 1/2. And so maybe this one is at negative 1/2, but this one's not. But negative 1/2 might be a contender. So let's try a negative 1/2 and try to do our division with that. So I'm going to set up my long division. I have a negative 1/2 over here in the corner, my 2, negative 3, negative 10, negative 4, and I'm going to start doing my synthetic division. Well, I do my my synthetic division, and sure enough, negative 1/2 does go in evenly, so it is a factor. Now what's left, remember this is my constant, this is my linear, this is my squared. So this is 2x squared minus 4x minus 8. I'm going to see if I can factor that. Well, immediately I can say I have a GCF, so I'm going to take out that GCF first. Now that I've factored out my GCF, I could try to do AC method, I could try to do box method, I could try to do guess and check. I always like guess and check, but any of those methods that I try, none of them works. This does not factor down. So what I have is I could call it x plus 1/2. I would really rather we call it 2x plus 1, because if I set 2x plus 1 equal to 0, that would give me a negative 1/2, and that's the negative I'm looking for, negative 1/2, times x squared minus 2x. Now this cannot be factored down any further, and so this is where I'm at, but I'm supposed to be finding my x-intercepts. I know what one of them is, but the other two, yeah, they were on my calculator, but I don't know what they are. I'm going to have to do the quadratic formula. So I'm going to take a minute to do quadratic formula with this trinomial. So I do my quadratic formula and I come up with these two solutions. And remember, these two are two solutions. I could convert that to a decimal and I could graph it. And when I did that, it would be these two points here. That's what would come out for my 1 plus and minus radical 5. My point here is that we list out the roots. Once we find the roots, we choose which one works from the graph, and that one was the negative 1/2. We confirm that negative 1/2 by doing synthetic division. If we can keep going, we keep going. But this one, as we looked on the graph, none of those other things were going to match. And so that told us it must be quadratic formula. And what this theorem specifically is stating, remember, is if a plus b radical c is an answer, then a minus b radical c must also be an answer. So what this does is it tells me my x-intercepts, or my zeros, or the roots. All of those words are, they are all synonyms with each other. So my roots are, I've got 3 of them. I've got a negative 1/2, and then I have 1 plus square root 5, and I also have 1 minus square root 5. Those are my 3 roots. Okay, we will talk about all of this tomorrow in class. The main focus of this lesson really is on graphing. So what we did on the first page is the main focus. Also at the top here with a multiplicity, that is also extremely important. And then this other stuff with the irrational roots, we'll get more into that the next day. But the rational roots is also important for us to know that we can divide and then divide that one and then divide that one and so forth. But like I said, we will get more into all of this tomorrow in class.